Hello, and Unit 7 begins with multiplying mixed numbers. Now you can see here I have the same problem. I have 4 times 2 and 2/3, and over here I also have 4 times 2 and 2/3, and I'm going to show you the steps to solve these. It's actually 2 different methods, but as you can see here and here, we do arrive at the same answer. Alright, so if you remember back, I think as far back as Unit 1, we talked about how to do this, where this 4 must be multiplied by both the 2 and the 2/3. You can see the work here. 4 times 2 is 8, and 4 times 2/3 is 8/3, which can be rewritten as 2 and 2/3 with a little division problem. The last step then is to go ahead and combine those to get our final answer of 10 and 2/3. So that's kind of what I guess I'd refer to as a review. We've done that back in Unit 1. Now the rest is kind of applying some skills that we've been learning over the course of the last several units. Starting down here, this is a way to organize what I just did up above. This is called the area model. Area model, very simple. Think of a multiplication chart or lattice, and you just do 4 times 2 is 8. And 4 times 2/3 is 8/3. I like this. It helps keep everything organized. This question's not too crazy, but when you get a mixed number times a mixed number, these boxes definitely help. All right, now let's venture over here to the right side. On the right side, you can see what I did was my 4 stayed the same, but I rewrote my mixed number as an improper. Now this changes the problem quite a bit. So once you do that, it's 4 times 8 is 32, and then 3 remains on the bottom. So now we need to simplify the improper fraction into a mixed number. Here's our division. We know that 3 goes into 32 10 times with 2 left over. We remember the QRD. The QRD stands for quotient. So my quotient is the whole number, which is 10. My remainder is the 2, and my denominator remains the same from the original problem, or is my divisor, which is 3. So either way, you get the same answer. You have to decide which one of these works best for you. There's definite positives to both of them, and it really boils down to personal preference. All right, our first question that we're going to look at here and work through together is going to be 7 times 3 and 1/4. We're going to start with that, then we'll come over here, and I already changed my 3/4 to 13/4, and that'll be our second one. I did set up my area model, or my boxes here, to help me with this multiplication, and you'll see that we're going to do 7 times 3, which is 21, and then we'll do 7 times our 1/4, which is 7/4. So now what we need to do is we need to figure out what is 7/4, because we realize that's improper. We don't like that. So we need to switch that real quick, and that goes in 1 time with 3 left over, so we get 1 remainder 3. 1 remainder 3, you remember our QRD, so that would be 1. My remainder is my numerator, my denominator stays the same. So it actually becomes 21 plus 1 3/4. We tally that up for 22 3/4. All right, now let's take a look at our question here that we converted into an improper. So we need to first do 7, which we can put the 1 underneath. 7 times 13. Let's not try to be too risky and try to do that in our head. So let's just take the extra 2 seconds and show our work. So we do 13 times 7, or 7 times 3 is 1. Carry the 2 over, and we get 91. So we'll get 91, and then the 4 on the bottom. Now we realize we're not done yet, so we need to put that into a division problem. 91 being divided by 4, and 4 goes into 9 2 times. And then we trying to show both methods at the same time here. We bring down that 1. So 4 goes into 11, looks like twice, with 3 left over. Keep track of it here. So my answer looks like it's going to be 22 remainder 3. All right, but then we have to remember our QRD, which reminds us that Our quotient is our whole number, so 22. My remainder is the numerator, and my denominator stays the same. And now you can see that 22 3/4, 22 3/4. So you just have to decide which one works best for you and which one you're most comfortable doing. All right, now we're going to work through a mixed number times a mixed number. It's the same thing that we did before. We have to take this 4 and go times the 2 and the 4 times the 2/3. But here's the difference. We also have to do that with our fraction. So 1/2 times 2 and 1/2 times 2/3. Okay, this is when the area model may be a little helpful. Make that a little bit smaller here. Just simply do a box. It doesn't matter which number you put where, you just need to make sure that the whole number stays with its fraction. So 4 1/2 goes together. Then we'll do 2 and 2/3 goes together. And now you just work your way through. 4 times 2 is 8, and 4 times 2/3 is 8/3. 1/2 times 2 is 1. 1/2 times 2/3 is 2/6. Now what we have to do is we just have to add all this up. There's so many different ways even to go from here to the end. 8 plus 1 is pretty easy, that's 9. And then I'm actually going to show a little bit of work right here in this problem. Now I see that I have a 6 and a 3. Now my 3 goes into my 6, and I can do that, make a slight adjustment by going times 2 to the top, and that's, I'll write it down here, so that'll be 16/6 plus 2/6. I can combine these for 18/6 plus 9, and my 18/6 actually equals 3, so I get 9 plus 3 equals 12. Pretty cool to think you can multiply two mixed numbers together and still get a whole number. So my answer works out to be 12. All right, so there's that. Now let's look over at the other half. You can see here I matched up, color-coded them. 4 1/2 converts over to 9/2, and 2 2/3 is the same as 8/3. We multiply straight across, and we get 72 on top and 6 on the bottom. Now the really cool thing about this, if you go with your math facts, and we've been practicing up to our 12s, so many of you probably realize that 6 times 12 is 72, so you could actually be done with 12, or if we wanted to show the work, don't want to take for granted that everybody is that quick with their 12s. They can get a little tricky. So let's go through and work. It goes in one time, which is 6. 1, we make that the 12. Keep track of it over here. We add our 0, so keeping track of both traditional division and my partial quotient. And then that 6 goes into 12 2 times. With 0 left over, goes in 2 times. So you can see that we get 12. So there's really the work. You need to decide what works for you. I would definitely say, and I think it's pretty obvious to see, that this side over here, if you have the skills to work this way, if you're really good and quick with your facts and can go from mixed to improper, and then from improper back to mixed, this is definitely the method. Or if you like to work with a little bit smaller conversions when you're down here with our improper and converting, it keeps your division problems a little bit smaller. So really you have to decide, and as I said before, it's really a personal preference. Now it's your turn to go ahead and practice a question for me. And now it's your turn to try these. What I'd like you to do is go ahead, please write these on a piece of paper, and I'd like you to work through 8 times 4 2/3, and also 4 1/2 times 5 1/3. Go back, that's fine. You may look back at what we did, and you may choose either process you like. If you would like to go mixed to improper, you may, or if you'd like to do the area model. So again, do these and hand these to me tomorrow, and get yourself into the drawing.